Hello, this is Tyler Beamer, Haywood Community College. This is an instructional math video for DMA 040. This video is in regards to Module 4, Section 3, Simplifying Expressions. Alright, so some vocabulary to keep in mind here. A term is a number or a product of a number and variables raised to power. So these are all examples of terms, and we've seen quite a few of these terms in algebraic expressions that we've looked at. So we want to be able to identify the coefficients of these terms, because that is important when we look at combining like terms. So this first term is what we call a constant. So a constant is basically a number that's going to remain unchanged regardless of the value of the variable. So constants are just numbers that are not attached to variables. Okay. Let's look at the second term, 5x to the third. Okay. A coefficient is the number that's right in front of the variable. So it is the numerical factor of the term, so it's the number that's multiplied times the variable. So in this case, this coefficient would be 5. Negative 4xy squared. That term has a coefficient of negative 4. Okay. Z squared, right? Even though you don't see a number, that's actually a 1 that's there. We can multiply 1 times any term and get that exact same term back. That's the identity property of multiplication. So this would have a coefficient of 1. Okay. Here's another one. If it had negative z squared, right, that would have a coefficient of negative 1. That would be a negative 1 in front of that. So it's important, now that we know what algebraic expressions are, to be able to dissect the terms, especially the coefficient, because we're going to use that when we look at combining like terms. So just more practice with that. Identify the numerical coefficient. So the numerical coefficient here is negative 6, 27, negative 1. And then for this one, that would actually be 1/19th, because there's a 1 that's right here, right? So we can actually have that as 1/19th times x. Okay, so it's important that we know how to define the coefficient, because we use that to combine like terms. So what is a like term? A like term are terms that contain exactly the same variables raised to the exact same powers. And then terms that are not like or unlike. Combining like terms, to combine like terms, we combine the numerical coefficients. So that's why it was important for us to know the coefficients, and then multiply by the resulting common variable factors. So let's take a look at determining whether things are like terms or not. So determine whether the terms are like or unlike. So notice that in order for things to be like terms, they have to have the exact same variable. These both have x, but those variables also have to have the exact same exponent. This has an exponent of 1. That's not written. This has an exponent of 2. Therefore, these would be unlike, because they do not have the same exponent. Okay, so what about these? Yes, xy, xy, these would be like terms. Okay, they do have the same variable, x and y, to the same exponent. And same thing down here, these would be like terms as well, even though they have different coefficients, the terms are the same. Okay. Here are some other examples of like terms. So if I had x squared y squared. Those would be like terms. If I just had x, these would be like terms. So like terms obviously look the same, hence the name like terms. They look alike. Alright, so how do we simplify? Now that we know what coefficients are, now that we know whether things are like terms, how do we simplify that? So the root word of the word simplify is simple. So essentially we want to take these algebraic expressions and make them simple, combine things together. So to do this, right, we combine the numerical coefficients and keep the like term part the same. So these are both like terms, they have x squared. So then we combine the coefficients 6 and 7. Keep the x squared part the same, which results in 13x squared. Okay, these are also like terms. Once again, combine the coefficients, so 19 minus 30, xy, keep the like terms the same. 19 minus 30 is going to give us negative 11 xy. Okay. Down here, these are not like terms. xy squared, x squared y, they both have x and y. Notice that the exponent of 2 is in different places there. So if terms are not like terms, then we cannot simplify them. So they would already be in simplest form. Okay. All right. So let's look at combining some of the properties that we looked at in the last section with the simplifying process. Okay. So notice we've got 4 times 2x plus 1 minus 8. Okay, so we want to simplify, we want to use the properties, we want to combine like terms, try to make this smaller, more simple. Okay, so first thing would be, I'm going to rewrite the problem, do the distributive property. So 4 times 2x is 8x, 4 times 1 is 4, and then I bring the minus 8 down. It's still in the problem, I haven't used it yet. So now try to combine like terms. 4 minus 8, these are both constants. Constants are like terms. So I combine those together. 4 minus 8 gives me negative 4. And then I go until I cannot simplify any further. Notice these are both unlike terms. One has an x and the other one doesn't, so that I would have to stop at that point. So this would be the simplified answer. Okay. Let's look at this particular problem. Okay. Use your distributive property first, right? Because I'll need to do multiplication before I do addition, following the order of operations. So I'm actually going to do 3 times 3x, which is 9x. 3 times negative 4, that's minus 12. So that's the distributive property. I bring down the 8. Once again, combine like terms. These constants are like terms, so I get 9x minus 4. Okay. I wanted to do 2 more examples here. Okay, so 4y plus 6 minus 6y plus 4. Okay, remember that there are ones that are in front of these parentheses, so I could do distributive property. Now when I multiply by a positive 1, that's not going to change any of those terms, but when I multiply by a negative 1, that's going to change the sign here of these. Okay, and then I can combine the like terms, so 4y minus 6y, right? So essentially combine those using the operation here. So 4 minus 6 is negative 2y. And then the constants are like terms. Positive 6 minus 4 is a positive 2. Okay. Alright, down here, do the distributive property first. So I'm really following the order of operations. So 5 times z is 5z. 5 times negative 2 is negative 10. Combine the like terms, which are the z's. So that gives me 10z positive. Negative 10 minus 2 is negative 12. And therefore, this would be the resulting simplified expression. So I continue to simplify until I have no other like terms. Okay. This is more of that practice with writing expressions with written words. So write each phrase as an algebraic expression, simplify if possible. Let x be the unknown number. So twice a number. Twice means to multiply by 2. A number, x plus 9. Okay. These are not like terms, so I keep them separate. Okay. 7 times the sum of a number and 2. So keep in mind that I want to take the sum of those of a number and 2 first, then times that by 7. So I need to use parentheses here. Okay, so be careful when you see questions like that. If you're multiplying the sum or the difference of two things, you want to put that in parentheses. This can be simplified because I can then do the distributive property and get 7x plus 14. Okay, so hopefully that'll help you get started. If you have any questions, as always, please email or come by the office. Have a great day.